Hi everyone, welcome to my channel Nirmal School. Let's start with first session of Theory of Computation. Let's understand few basic concepts like symbol, alphabet, string and epsilon. Symbol. What is symbol? Symbol is nothing but any single element. For example, if I say 0, 0 is considered as single element or 1 or 2. Based on the requirement, we can define the input and symbol is part of input. So we can say any single number from 0 to 9 can be considered as symbol, or we can say single A is also symbol, or single B or C or any character from A to Z can be considered as symbol. In some cases, we may need to understand or we may need to consider any special character as a symbol also. That we will see when we resolve the problems of finite automata. On the basis of this definition of symbol, let's define what is the alphabet. Alphabet is nothing but a set of symbols. This set should not be empty, it should be non-empty. It should contain some fixed number of numbers, characters. That's why it should be a finite. For example, I can say set of 0, 1. This can be a set of symbols or set of binary numbers, set of 0, 1. As per the requirement, we can define it in any way. Set of symbols alphabet is denoted by sigma. Sigma can be a set of binary numbers or characters A, B, or I can say all the numbers from 0 to 9. But notation should be a set notation, and this is what sigma, using the sigma we can denote it. Now in your mind there might be question, what is the application of this? Let me tell you one example. If I say sigma is 0, 1, set of symbols 0, 1. From this set of symbols I can write down some numbers, or we can say some sequences, and that sequences is nothing but a string. For example, initially I will write down the single 0. This single 0 becomes the string. I can write down the single 1. This also becomes the string. If I want to write down another strings like 0, 0 or 1, 1 or 0, 1, or I can say 1, 0. I can write these strings in any sequence, like first start with the 0 followed by 0, start with 1 followed by 1, then 0, 1, 1, 0. So any sequence of symbols, using this we can write down the strings. Another example, if this is the symbol set A comma B, if this is the alphabet, I can write down the string single A or single B, or I can say double A or AB. So any sequence of these symbols is nothing but the string. So this is what our next definition, string. Any sequence of symbols over the given alphabet. For example, alphabet is here A comma B. Then what are the strings possible? Possible strings are A, possible string is B, or I can say double A, AB, or any string which is of any sequence. Here one more point I would like to explain. Here string is A. What's the length of this string A? It's a 1. String is B. Length is 1. If I say string is double A, AB, BA or BB, what's the length of this string is 2. So when we write a string over the given alphabet, in exam or in next some session we will understand there will be some condition given. For example, like this, write down the strings starting with A. So based on this condition we need to write down the string, that we will see in the next session. So let's see the next last terminology, epsilon. Epsilon is also one of this string, but only thing is that it's an empty string. Empty string, so but obvious its length will be a 0. So it defined by the symbol epsilon whose length is 0. Like string A length is 1, string B length is 1. Similarly, epsilon length is 0. At this moment, it will be difficult to understand what's the use of this and what's the application of this. But let me tell you, this epsilon will be useful when we will learn regular expression or regular language. Also, this epsilon will be useful when we will design deterministic finite automata in next few sessions. Let me explain few more examples of this epsilon. If suppose string is A, then it is similar as epsilon dot A or A dot epsilon. If string is AB, it is similar as epsilon dot AB or AB dot epsilon or in between epsilon, or we can also write down this AB like this. Before A, empty string epsilon. In between A and B, empty string epsilon. After B, empty string epsilon. Last example, TOC. It can be written like this like this, or in short, again, if we write string like this epsilon is present like this also. So this is what empty string whose length is 0. At this moment, what you need to understand, there is something called empty string whose length is 0. So these are the basic concepts that we need to understand before designing deterministic finite automata or any finite automata. All these concepts will be useful in complete theory of computation. In next section, we will try to write down some strings with some given condition over the sigma a comma b or sigma 0 comma 1. Thank you for watching this. We'll meet in the next video.